All right, mic check, good. So I'm Max Ceron, Max Ceron, CWB Association Welding Podcast. Today we have a really cool guest, Welding Podcast.
The show is about to begin.
Hello and welcome to another edition of the CWB Association podcast. My name is Max Ceron and we are here on day 3. And it feels like a long 3 days, but they have gone by in the blink of an eye. We have had a fantastic time. And if you'll notice by my voice that this has been a lot of talking. And we have Gordon Attridge here from AGT. He's going to be kind of talking about his experience over these last 3 days because I think we're both tired.
Definitely. And I share with the show throat syndrome with you this morning.
Yeah, if you don't notice it until nighttime. Last night, I was worried about today's show. I was like, wow, my throat is rough.
Yeah, I felt it this morning.
Yeah.
Yes.
Did you bring any lozenges?
I did not.
I have some I can share with you if you'd
Okay.
like.
Thank you.
Now, you guys have a great booth here at the NASCC, and it's quite a large presence that you guys have brought. Is this kind of like are you planning to do big pushes like this going forward with conventions? Because it's been kind of like shut down for 2 years, basically.
Yeah, absolutely. I think, and we learned that back in last fall at FabTech in Chicago, which was the first time that we brought the type of equipment you saw here at this show. And the response, in the past, we would bring videos, we would bring a static display, and we got good responses. But by bringing the actual equipment and displaying and letting people actually try it and kick the tires here in our booth, it made a huge difference. The traffic in the booth is dramatically increased, and we're selling product from our booth as a result, which is something that hadn't happened in past years.
And that's something that we were talking about before, and I've heard this whole week. And I was also at FabTech in Chicago, which was a little, everyone was still scared about, and rightly so, about COVID and what was going on. But everyone came out of FabTech with a renewed sense of how conventions can run. Before it was much more of a, rolling your ponies through the show and everyone kind of looks and then you talk about it after. And it's now everyone's going home with ponies. It's kind of a different idea, right?
Exactly. Yeah, and I think you mentioned, if you're going to venture out into the world of COVID and there's some risk involved, you're not going just for some casual purpose. You're not just going to pick up brochures and take them home. You're going to go out and make a deal. And I think that's what's been going on.
Yeah, you take your wallet with you.
Exactly, yeah.
So let's talk a little bit about you, Gordon. You're a Canadian.
Yes, I am.
Are you still a Canadian?
I still am.
Do you hold dual citizenship or just Canadian?
No, I'm a permanent resident alien. So I'm a Canadian true and true.
And where are you from in Canada?
Born and raised in Woodstock, Ontario.
The famous Woodstock, Ontario, which is now a very expensive place to live.
It's getting to be, yeah. I kind of wish I'd hung on to some real estate.
Yeah. And I read your bio, and it was very interesting because you have, by your own words, a very extensive welding background.
And almost not by choice.
So you took welding in high school?
I did. Back in those days, shop trades were required courses. No matter what kind of ambitions you had for your future, you were going to be stuck into electrical and woodworking and automotive and welding. I think were the 4 trades that we were exposed to.
And did you like it?
I liked it, but I sucked at it.
So it didn't like you?
It didn't like me, yeah.
Now, when you came out of high school, what was your goal initially? Were you looking to be in the trades, or were you thinking something else?
No. As from probably an age of 6 years old, my heart was set on being a marine biologist, if you can believe that.
Well, I totally get it. I want to be a robotics engineer. Although, I guess full circle, I'm not that far from it now. I'm in the same room as robots and engineers. So
you're a lot closer to that than I am to marine biology.
Well, I don't know. I had some sushi last night, so So you came out of school. So did you start your college careers thinking marine biology?
No, I came from a pretty modest background, so funding for 4 years of university wasn't readily available. So I looked around for a summer job that I could, get some cash and earn my way through school. And it just so happened that my first summer job was for a company called Hobart Brothers. They're no longer in the business, but they were one of the big 3 back in the 70s when I went to work, with Miller and Lincoln being the other 2. And Hobart Brothers had a factory in the Woodstock area. They hired me on to spool welding wire, which I remember my interview. At that time, I weighed all of 120 pounds soaking wet, and the spool packages weighed 60 pounds. And they said, "Are you sure you can pick one of these up?" And I demonstrated that I indeed could.
Yeah.
And
Can you do that for 8 hours a day?
yeah. Actually, I was probably a little more buff then than I am now. But yeah, it worked out. It was a great place to work. It was close to home. It was a good company with good values, and they were also looking inward for talent. And I didn't have to work very long. I think it was less than a year. I was working in the factory operations when they offered me a promotion to the office for inside sales.
And was that something you had thought about while you were working there that year as a manufacturing person on the floor, being like, I'm looking to get into an office job, or did it kind of come at you and you're like, oh, maybe?
Yeah, it really wasn't my ambition. I was still looking to keep saving and for my educational opportunity. And then I thought, if I'm going to make money sitting in an office versus slugging 60-pound coils of wire every day, that might be a better choice.
Yeah,
And
brochures weigh much less. I guess maybe not. Maybe if you got enough of them. But so, how was the learning curve then as a young person getting into sales? Like, I don't feel I'm very good at sales. I feel like it's a skill that I can kind of fumble my way through. But over the years, I've seen some people just be amazing at it. So, as a young person getting into sales, what was some of the things you had to pick up?
Well, it was a gentle introduction because I was moved into inside sales. So I spent a lot of time on the phone with customers and distributors that were looking to buy something. I wasn't having to sell it. So I was basically servicing order requests and that sort of thing. And then exposed to our sales team that was working with customers in the field. I spent probably 18 months doing that. And I'll admit, I am not a natural salesperson. I am an extroverted introvert. So it's one of those things where you need to actually put an effort in to wear that skin.
Put the face on and get ready.
Exactly.
Yeah.
So it wasn't easy at first, but you develop relationships, you develop a rapport with people, and I really enjoyed that job. You looked forward to talking to people every day or every week that were calling in, your regular clients, and trying to help them.
So this is like 70s or 80s, around there?
Yeah, this was... I started in the factory in the late 70s, and I was moved into full-time out in the field sales in 1981.
So how extensive was the Hobart, line of products at that time?
Oh, it ran the entire gamut of filler metals and welding power sources for every process. So it was a big deal. Hobart was a privately held company back then, and I think back in the late 70s, they were still a $400 million company in terms of annual sales.
That's very large. And
for that time, yes.
Yeah. And then, you did this you said for about 18 months.
Inside sales,
yes.
Yeah.
And then what happened?
Well, then they decided to put me in the field, and if you're going to be in the field, you better know how to weld. And I remember panicking, thinking back to my days in high school and my capabilities there. But they were very patient. There were some excellent craftsmen there. Even though they were in sales, they had practical welding skills that were really, really to be admired. And I spent my first summer, probably 3 or 4 months, every day welding with a different product.
Getting to know the line.
Helmet down, eating smoke for 8 hours a day. We couldn't do it in January. I had to start in August.
Yeah,
so
of course.
It was
nice and hot.
Yeah, exactly. So I sweat through that. And by the time that was over, I was a pretty fair welder. I mean, I guess I was a pretty fair welder with all processes on a 14-inch long steel plate doing a fillet weld.
Yeah, with perfect clean material, like nice table.
I could work on some different conditions, but if you put me in the field and said I need you to weld this vertical up for 4 hours a day, that wasn't going to be me. But I could definitely use all the processes and had understanding of all the parameters and how they worked.
And for young people looking to get into sales in the steel trades world, how important is it to understand that practical sense of what you're trying to sell? Like let's say you're looking to sell a machine, you know how to use it. If you're looking to sell filler materials, you know what they do. How important do you think that is in the sales world?
Oh, it's critical. When you're talking to the customer, you're generally not selling to the owner or to the shop foreman. You have to sell to the welder. Even though someone else is making the decision, they're looking for the people on the floor to advise them. And so you need to be able to speak their language, and you need to be able to meet their objections in the course of making that sales call. So if you can't demonstrate that you have some ability to weld or you understand their job, it's going to be really hard to reach them.
Yeah, especially if they're saying like, well, I've had this problem. What do I do? You want to have some type of answer.
Or maybe they don't have any, or maybe they don't know they have a problem.
Oh,
You're
right,
trying to
right.
convince them that your product's going to solve something that they don't even know they're struggling with. And those can be really difficult things to do. I think impossible to resolve if you don't know how to reach to that person and show them either by demonstrating the capability yourself or helping them demonstrate it themselves.
Okay, so you got thrown out into the field, and there's a whole nother learning curve. You had to learn how to weld for starters.
Yeah.
How is the relationship side of it now, being in front of people as an introverted extrovert? Now you're knocking on doors, you're walking into shops, sometimes hostile territory. Well, what's that like?
It was terrifying. I was. There were a lot of days, especially when you knew you're going into enemy territory. So a stronghold of your competitor, thinking you were going in to try and break down the doors and get them to buy your product. And let me take you back to 1981. We were all wearing suits and ties as we went into shops. So there was none of this jeans and that sort of thing. No casual wear. We were suits and ties. So I walk into a shop. I'm, a 21-year-old kid. I'm wearing a suit and tie, and
Probably your dad's.
No, I think it was my choice. Probably wasn't a good choice, but it was my choice. And you'd walk into the shop, and here's this welder with the beanie on and leathers, and he's looking at you thinking, I've been welding for twice as long as you've been alive, and you're in a suit and tie. What do you know?
Yeah, what are you even doing in here?
I can tell you that I made a choice early on to make sure that any suits or any overcoats I was wearing were made of wool, because the polyester stuff didn't last very long in the welding environment.
No, and it's dangerous. It melts.
Yes. But every single suit coat I had, or any overcoat that I had, if we were welding in the wintertime, every one of them had
Little holes.
Spatter at the corners of your insides of your elbows.
Yeah.
From welding and having spatter hit it to show this guy, I know what I'm doing, and I can show you how this product works. And you could gain their confidence, and you could gain their respect by doing that.
Some form of trust, which is, we've interviewed a number of people throughout the day, and obviously at a convention, there's a lot of sales persons here. It's probably the majority, right? And that topic of trust comes up all the time. Trying to develop that trust with your customer that they're going to buy your product. But I'd imagine, we were talking about it last night as a group. It's like, if you got 100 people in a room telling you to trust me, how do you know who to trust?
Yeah.
Right? It can be overwhelming, right?
Yes. Yeah, exactly.
So how do you approach that as a salesperson coming into a conversation?
Well, and again, back to my extroverted introvert status, I didn't have a pushy sales approach. I was a consultant. I wanted to approach it from a technical side.
Work with them.
Exactly. Yeah. And if you can help them solve a problem, then you're going to gain their trust. And that's how I approached it. It's not about what you say, it's about what you do. And that was my technique. It worked for me. It might there's certainly people out there that have that innate sales skill that
pizzazz.
Can convince people. Exactly. And there are people that warm to that kind of approach. But this is something that's worked for me throughout my entire career. Till today, and I think that it served me well in helping me to gain the customer's trust and their confidence.
So how long were you doing the outside sales or in-person sales with Hobart?
Actually, for the rest of my stay there. But what happened was that they really set me loose into the wild in 1981, and I was again selling our full slate of filler metals and welding equipment. And in the course of that, 81 was about the time that Hobart hooked up with Yaskawa in Japan to market Yaskawa's robots in North America. And I was invited to tag along with the crew that was going to Troy, Ohio one day to our corporate offices to have a look at this new product.
That's cool.
And yeah, I didn't know anything about robots. I grew up reading Isaac Asimov books.
Yeah,
and so
the Foundation series.
Exactly.
Yeah.
So robots were in there, but they weren't industrial robots. So I went down and took a look at this, and I fell in love immediately. And I think all those days of sweating in our lab, learning how to weld, I thought, if you could get a robot to do this, that'd be a whole lot more fun. And I know that wasn't what my management was hoping I was going to do. They were really hoping I was going to sell a lot of welding wire and a lot of welding machines, but I couldn't help myself. The fascination was there with robots, and it was like I'd found my way.
Yeah.
And so I continued to sell in my territory, which at the time was Southern Ontario, sell all of our products, but I was always looking for opportunities to sell a welding robot. And in 1982, I was able to work on our first one. I wasn't the salesperson. One of our folks in Toronto had actually sold it. In a typically Canadian application, our first robot sale was to a company making snowblowers.
Okay.
So and
It makes sense.
It
Lots
does.
of manufactured parts to engage metal. Yeah.
And the second sale, I think, was to weld the GT snow racer frame. Do you remember those?
Well, absolutely.
So
we were poor kids. Like, we come from a fairly modest family, I guess is the right word. But I would just always see the rich kids have those GT racers, and I was so jealous because they look so cool. You could steer them, for crying out loud.
Yeah, they were awesome.
And they had brakes.
And they were popular.
Yeah, they were very cool.
And our customer, the same one that was making the snowblowers, our customer couldn't make them fast enough. They were actually importing them from Europe on cargo planes.
Wow.
So they were paying air freight to bring these in order to meet the
Demand,
Christmas rush and that sort of thing. So the first thing we did was after the snowblower application was help them set up a job to weld those GT snow racer frames with robots.
Awesome.
And I had stuck my head into this so deep that I became the programmer, the robot trainer, and the troubleshooter. So I was continuing to do my day job in selling welding process equipment and welding flare metals, but I was taking on this role of a robotic technician.
And there's always this kind of interesting gap in knowledge for people that we talk about robots and automation. We endlessly talk about it every year, and it's almost like there's still this concept of like, wow, this new push for robots and in the industry, but they've been around for a long, long time.
That's 40 years ago.
Yeah. And, that's when they got here. That they had already been like undercover for a while by the people that were using them before they hit the mass market.
Yes.
Right.
Yeah.
But back then, I would say, aside from all the differences, and I remember robots in the 80s, the programming was very tedious of the robots back then. I mean, now people complain about G-code. G-code is still easier than what was around back then. If you weren't, there was punch cards for many of them. And I remember on the first automated equipment that I worked on, you're having to program it in a computer, create punch cards, enter them card by card, and if there was a mistake, you had to delete the whole damn thing and start all over. Yeah. So this was your game. You loved this.
I wouldn't have loved it in the punch card era. I was just came in after that.
Yeah.
But today we have robots have programming pendants that look like Game Boy controllers, right? Touch screens and all kinds of shortcuts. Back then it was a metal box that weighed about 8 pounds, had a flock of buttons on it and no display. So you had to walk back to this huge refrigerator-sized controller where it had one LED display to know what line you were on.
Yeah, and you had to know the number. You had to keep a notepad with the numbers.
Yeah, I think we did our backups on a Sony tape recorder. That's what the programs were backed up on. But even then, that was still cool technology
still
based
cool,
on what we, based on the punch card era. And to me, it was being able to take what I knew about the welding process and then the motion requirements and put them into something that was so repeatable that it could generate the same weld at a very high quality time and time again. That just fascinated me. And that nobody had to be there watching it do it.
Yeah, and it didn't complain. It didn't need coffee breaks, and it didn't, the things that you look at from a production point where it's like, well, how can I keep my shop producing all the time, right?
Yeah, exactly.
So what was the cost of a machine in 1982?
I can remember that. A robot with a welding machine and an interface and a torch was 127,000 Canadian dollars back in.
That's not bad.
In today's dollars, it's a lot.
How much would that be in today's dollars? I don't know what the inflation is over 40 years.
I don't either, but I know, relatively speaking, it seemed like a lot of money back in those days.
I wonder what median or wage would have been in 82. Like, we were in Canada already. I bet my dad was probably making about 30 grand a year. as a Boilermaker. So if that's, say it's triple now, no, it'd be 4 times more. So would it be around $600,000? I mean, that's not. Robots have gotten down in price, I think, significantly.
They're manufactured in huge volumes compared to back.
And the
in those
used
days.
robot game. This is something I just figured out a few years ago, is because the robots have gotten so popular and there's so much upgrades constantly happening. Now there's the whole used robot game. So like if you're a small company, you can buy a used robot that's already got hours on it, but it's half the price.
Yeah.
That's also got its dangers, because then it's who's going to service it, blah blah blah. But it's interesting how the arc of the robot has moved throughout the years.
Yeah, absolutely. And even though they were kind of crude devices back in the early 80s compared to what we have today, they were still really reliable.
Mm-hmm.
One of the first robots I ever sold was still working 15 years later. So yeah, there's a risk when you're buying those previously enjoyed robots. But if they've been well maintained, it's easy to get another
Parts,
10 years out of them.
yeah.
Sure.
So then, after you were now working with robots, is this sort of becoming your job? You're now the robot sales guy?
Yeah, it's funny, and maybe to your listeners, one piece of advice I can give is be the job you want.
Mm-hmm.
If you're lucky enough to have the opportunity that I did, where they gave me that latitude, and I was always focusing on that instead of my
what you were supposed to be
assigned
doing?
role. Yeah, they finally decided, well, if he's going to do that, let's just give him that title and let him be the robot sales guy. And yeah, exactly. That's what happened. They gave me the role in robot sales. It was kind of challenging, because
Mm-hmm.
if you think about it, back in those days, there were no schools for robotics.
Mm-hmm.
I was self-taught. If I wanted to learn, I had to go after work and go into the lab and turn the robot on and learn
And play.
play. Exactly. And there was no issue with that. I loved doing that, and they were quite happy to let me do that. So self-taught, with again the support of some really good people in the organization that also had some good experience, and grew into that position to the point by 8 years later they made me the general manager of that group. So we had quite an automation group at that point, where we weren't just selling robots, but we were selling integrated robots into some solutions, and working not only just with our end customers, but also with integrators and machine manufacturing partners.
So at this point, is Hobart still working with Yoskawa, I think you said, as the robot supplier and kind of integrating systems together? Or had Hobart started to look, as many companies do, at creating their own line of robots?
In 1989, Hobart created a joint venture with Yoskawa. Up until that point, we were a customer, so we were buying and exporting robots. Actually, at that point, we were exporting them directly from Japan to Canada, and assembling them and delivering them to customers. In 89, Motoman was formed, and that was a 50-50 joint venture between Yoskawa and Hobart Brothers.
Okay.
And so we maintained our relationship with Yoskawa directly, but we also were getting more and more support from the Motoman organization in Ohio. And so that's where we eventually migrated to. So we were still Hobart Brothers in Canada, but we were buying our product through the Motoman organization now in the U.S.
Yeah, and I believe Motoman and Yoskawa are both exist today, don't they?
Well, Motoman is
For
Yoskawa.
sure. Yeah,
Today it's
okay,
called Yoskawa Motoman
Oh,
Robotics.
right. That's why I was thinking.
Yeah, eventually Yoskawa bought out that partnership, and it was solely owned by Yoskawa.
So when did the ITW takeover happen with Hobart? I think it was around the early 90s, wasn't
96
Okay.
is when that happened.
So were you
yeah.
still there when that went down?
Yes, yeah. I was still leading the robotics group.
And what was that like? Because that was huge news in the welding world when that went down. Because it wasn't just one company; it was a number of companies all kind of rolled into one large, umbrella. You had invested many years at this point into the company.
Yeah, absolutely. I'd been with Hobart since 1977, so it was almost just a few months shy of my 20th anniversary when the change came. It was challenging. I mean, you're part of a family-owned organization. Mind you, it was a big family organization, but when William Hobart walked through the Canadian office and could call me by name, you felt like you were part of something. And I think at that time, ITW had 20,000 employees, so it wasn't going to be the same kind of relationship corporately. And at the time, it looked like their direction wasn't going to be to continue to pursue robotics.
Oh, that's kind of daunting for you then.
Yeah. So I remember one of those early conversations where, my feeling as I walked away was I'm not going to be able to pursue this.
What you really love.
My passion in robotics, and so that's when we parted company. When I realized it wasn't going to be the same.
Now, with your years of service working with robots and customers and the trades in general, when you left ITW now, did you immediately have your eyes set on another robotics company to go work there and try to continue this passion?
Yeah, I mean, I'd had a long-standing relationship with the Yaskawa people since 1981, and so I looked to them to see if there was an opportunity. They were also terrified by the ITW acquisition and thought that they were going to lose their channel to the market in Canada. So they had a plan to organize a startup in Canada. And so eventually I found my way into that role as general manager for Yaskawa Motorman Canada and really started up their operations based out of Mississauga, Ontario.
So now are you in a position where you almost have to compete against your former employer?
Yeah, it was a little uncomfortable. I mean, still had some good friends there.
You still know people there.
Yeah, had 20-year relationships there. It made it a little uneasy at times.
Well, it probably made them a little uneasy too, being like, that was our specialist. That was the person that knew the most about this product is now working for our competitor.
Yeah.
Now with ITW taking over, eventually, I mean, they did stick with robots. Obviously, it's not something they could just ignore. What did they have in terms of what they produced? And you now with Motoman, did they have their own line come up out of their the phoenix rising out of their ashes?
Well, they switched to different brands, and I think they were, with the Miller organization, they already had some associations with other products, and then the Hobart crew in Woodstock were looking to kind of continue their own unique thing. I think when you're bringing a big organization like Hobart and Miller together under the same umbrella, I think there was a lot of soul searching. How do we make this work? How do we avoid
how
competing?
do we mesh this?
Yeah, exactly. How do we mesh without sacrificing or cannibalizing our own business internally? So, I don't know a lot about what went on there in those days, but I know it was probably a pretty traumatic time trying to figure out what was going on. But they pursued robotics on their own with a new plan. And eventually Miller did, they've got a unified strategy now under the Miller brand.
And how exciting was it to be a part of a startup kind of branch in Canada? And it's like, okay, here we go, clean slate, man. Let's get this going. There must have been a lot of excitement and also pressure to get this off the ground and launched.
Well, it was amazing.
Yeah.
And they say that teams are best forged under stress and pressure, and we had a great team of people. Interestingly, when you do leave an organization, you do take that knowledge and the contacts and the technology with you. You have to be very careful about how you play in the market. So we had a strong competitor in the Hobart organization. We had to make our way without relying on any of those old contacts, or try and play the game
nice,
in a way that's up above board, and you're using as much integrity as you can bring to the table. So. And everybody that went along in the Yaskawa organization they were up for it, and we had our first year was fantastically successful, and we grew consistently for the next 3 years. It was a lot of fun. It was a great team to be part of.
Did you guys start with a small branch and then immediately have to get bigger? And was there expansions going on?
Actually, Motoman actually planned ahead, so they put us into a facility that had room for growth. We kind of walked by a lot of empty offices for the first 6 to 8 months, as we were starting to grow. So we managed very well that way. It wasn't a tiny office; it was a really nice presence. They didn't last in that too much longer after we got started. They had to build a new facility to accommodate the growth, and they're still in that facility today. But it was. Sometimes we had to walk to find company in the organization, but it was a great time, great experience. It was really well done.
And your role then would have been kind of like CEO of Canada or
General manager.
General
I
manager?
reported to a VP sales in the U.S.
Okay.
But I oversaw all of our operations, the training, the technical team, and the sales team. But we, as a branch operation, we had a lot of support from the folks in the U.S., so we didn't have to duplicate all of the functions.
Yeah. And how did you see this for yourself? At some point, you must have stopped and been like, I didn't really like welding, and I got thrown into sales, and then I got thrown into the field. I love playing with robots. Then I got to sell a robot, and now here I am, general manager of a whole robotics selling and training facility.
I think that's when I realized I wasn't going to be a marine biologist.
You're like, well, I guess I'm not going to university for that.
I know I've stopped several times and thought, this isn't on a map. I didn't sit down and chart this course, but it seemed like doors were opening, and the doors were allowing me to go through and continue to do things that I really enjoyed doing.
Mm-hmm.
And once we had the Motoman organization established, it wasn't just arc welding. Now it was robots for material handling and packaging and palletizing and all kinds of different applications. So now it was real robotics. It wasn't just robotic arc welding.
Yeah.
We were still the number one market share in robotic arc welding. We still had that skill set and that background, but we were able to try on a whole bunch of new and different things. So that was kind of exciting too.
And how long were you a part of this journey with Motoman?
Yeah, less time than I'd hoped. I really saw that as a great opportunity, but the organization in Canada was never going to be fully capable of doing integrated solutions where, we were selling robots to integrators, we were selling robots to end customers, and we were doing some small systems on our own, but to take a customer challenge and create a total solution for it and give it back to them
Just wasn't there.
wasn't in the cards.
Yeah.
So I kind of got bored with the role and just selling robots.
Yeah.
And so I started. Actually, I didn't look around.
Someone came knocking?
Somebody came knocking and saying, "Hey, we'd like you to come and join us and help us to grow our company." And that was a company called New Tech Engineering. So that was 1999.
Okay.
That I joined the New Tech
And
organization.
what was New Tech's shtick up until that point?
Yeah, they were a small integrator, probably 30 employees, and it had kind of grown out of Rumble Automation, and then through FH Welding, and then the founder had actually worked through those organizations and set out on his own. I don't know, probably in the late 80s to create his own organization. And they had good welding roots from the automotive industry. They've been doing a lot of robotic welding or automated welding. It wasn't all robotic.
Yeah.
And some other general automation, but the primary focus was on welding. So it was a good fit, taking my robotics background and welding background and marrying it up to their existing business.
And they were about doing full systems integrations, like front to back, one-stop shop.
Design, build, custom automation, yes. Yeah, absolutely.
And so where did you fit in that puzzle? Were you like overseeing the whole thing, or were they bringing you in to kind of work on the robotic stuff?
Yes.
Both.
So as general manager for that organization, I really oversaw the sales initiatives. The founder was overseeing the engineering initiatives, and then we kind of co-managed the operational side. And really, I think it was about trying to bring the robot experience, the robot capabilities into their existing customer base to grow our business with those customers. After probably 18 months, we weren't doing dedicated automation anymore. Everything we were doing was robotic.
Yeah. Now, it's interesting for me, since I don't know the scope and price point of a fully integrated system. I'd imagine it's quite complex and could get quite expensive. As a welder, I would say, I would bite the bullet and buy a $10,000 welding machine, okay? I'd use it for 3 or 4 years, and then the Hobart or Miller or Lincoln or ESAB rep comes knocking by and says, there's the new machine. It's also $10,000. I know your machine is perfectly fine, but you should buy the new one because it's less fumes or less power or whatever the thing is. And that's a big deal, right? Because you got to basically get rid of a machine that's working to replace it with a newer machine that's working, and then maybe get rid of that or pass that one down or whatever. But in the robot world or this integrated systems world, as a company, I invest $15 million in getting this whole thing set up. And then how do you go back 3 years later or a year or whatever time frame it is and say, knock, 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 we got something way better. Are you ready for another $15 million investment? Like, what's the cycle of sales there?
It's different by industry.
Yeah.
So automotive has its own cycles built in, and it's model years, right? It's model changes.
Okay.
So you could see someone in the automotive industry would buy a custom automation for a part, a component for a model.
Mm-hmm.
And as long as that part didn't change,
Or too much.
Yeah, or too much, exactly.
Yeah.
They'd go on making 250,000 parts per year for the next 4 years. And then bam, that model's gone. There's a new one, they're going to retool. But they just made 1 million parts on that investment. So it's okay.
It's made its money.
Those robots may be redeployed by the customer, but quite often they're the ones that end up for sale as used robots.
Yeah, on the eBay of robots.
Exactly. So they basically just part that out and they start all over again with a new system. If you're a fabricator that's making components for the ag industry or construction, and you're making, buckets or loader arms or whatever, you don't have 250,000 parts a year to use to pay your machine off with.
Mm-hmm.
You have thousands, and you have a high mix of product. You have a low volume, so you want that machine to last as long as it can. And those are the systems that would be deployed for 15 years.
Yeah.
Because
as you design new equipment, you try not to change those parts so that the machine doesn't become irrelevant.
Yeah, but the great thing about a robot is it's totally programmable. So if your part changes, you can change the program. It's not like a dedicated solution. And there might be changes to the fixturing to accommodate the changes, but those might be re-engineering and modifications. But you would keep the core of the machine, the robotics, the positioning equipment, the welding equipment. It would always do what you bought it to do, and it's always more productive than the alternative.
Yeah.
So you didn't see, I don't think I've ever seen people trade that kind of product out just because there's a new thing.
Yeah.
Unless it's significant, or you've got a machine now that's 10 or 12 years old and it's getting harder to maintain, lack of spare parts, that sort of thing.
Now, in terms of, the progression of robots, and correct me if I'm wrong, what I saw was a quick push to make the robots awesome. And I saw this like working in manufacturing. They became more articulate, but more precise, lighter, not so heavy on the footprint, which was a big problem initially with the first round of robots, first generations. But then I really saw a change in the fixturing. And a whole, like, the fixtures kind of got ignored for a long time, I felt, where it was almost like a static big machine with a big arm that could do a bunch of stuff. But then all of a sudden you started seeing the fixtures moving around. And then I saw like another big leap in the advancement of robots and people looking at robots differently. When you're working with these integrated designs, how do you approach both sides? Do you separate them out, like, let's work on the robot for the part, or let's work on the fixture, or how do these mesh, or does it all, you want to offer as many possibilities as possible?
Well, it's you try not to engineer things before they're sold, because it's a lot of non-recurring engineering time that you can't get back. So, this is the CWB podcast, so we have to talk about welding.
Yeah.
You start at the weld.
Yeah.
And that's where we were really successful, because we started with what's the requirement of the weld. You put the wire in the joint. Where does what's the work angle? What's the travel angle? What do we need to do as far as process is concerned? How fast do we need to go? And that drives all the decisions from there back. Yeah. So you need to know, how is the robot going to make its course along this part? Where does it need to access? How many different positions do I need? In welding automotive parts, it's all about speed. So you want to make sure there's no obstructions. You can weld as quickly as you can. That drives a fixture design and a positioning design of one kind. If you're in the ag business and you want to weld a big loader arm, you want to put all those welds in the flat position if you can.
Yeah, because they're big welds.
Big welds. Yeah. You want to maximize weld quality, maximize weld speed. So that drives a totally different solution from a positioning perspective. And it would just become apparent as you started with the welding requirements and worked your way out. Yeah. And fixturing too. So what's the part geometry need to be at the end of it? And some of the most challenging jobs we did at NewTek were were really weld-intensive automotive parts. And if you think about the engine subcradle in a car, this is the part you bolt the engine into it, and then you lift it up and bolt it onto the subframe or the underbody of the car. It's a part that probably weighs 40 pounds, but there might be 7 meters of weld on this part. And they're small welds. They're 1/8 inch fillets, or sorry, let me do that in metric. So 3.2 millimeter fillet welds, 3 or 4 millimeter welds.
Yeah.
And you got to go as fast as you can. I'm talking like 40, 50 inches a minute or faster, depending on the weld process you're using. And you're going to have 4 robots welding on this part at the same time. So you just put 7 meters of 4 millimeter weld onto this 30-pound part. It's going to distort like crazy.
Yeah, and be hot as and it's going to need cool down time. And,
so that you had to develop a science where you're clamping the part out of shape so that when you weld it and let go of it, it meets the customer's dimensional requirements. And that's a black art, I can tell you.
Yeah, no, and that's actually something that I loved doing in manufacturing. I used to work for Brandt Industries, and I was part of the jig development team, developing the jigs on custom and small batch repeatable parts. And a lot of it was building the first one, seeing how it pulled, seeing where the distortions were. And then it's kind of it's an art. It's a little bit of guessing of how to set it up and so that it comes out right when you're done with heavy welds in manufacturing. Some of these are logging or mining components, and you get really good at it. You get to really know, like, this is going to pull that way, and you start seeing it into 3D. It's not just left and right. There's like degrees of variation. If you have a weld going in a arc, that gives all sorts of crazy distortions. So
yeah, it's challenging, but it's rewarding too.
Now, how long were you with this Nucor? What was it called?
NewTek.
How long were you with NewTek?
Till I was 13 years with NewTek.
So that's coming up pretty recently now. We're kind of getting to the current stage.
2012.
Okay. Yeah. And what happened with the company? Was it still going? Did you left? Or?
It was there was new ownership there, and kind of a change in focus, and more of a change in focus to 100% automotive. And for me, automotive was kind of the way to pay the bills. But my real love of my passion there was the high mix, low volume applications, the heavy weldments, big parts. How do you position them? How do you weld them? And how do you program them?
Yeah.
Because big parts, and if you were doing some big stuff for Brandt for logging and mining, you could spend weeks programming a part. And the challenge was, if you were spending weeks programming a part, you weren't welding anything because your robot was tied up with you in a teach pendant. And so I think in the early 90s, I started looking for ways to relieve the programming burden, make it faster, or take it offline so that you could actually be in production while you were programming something.
Simulation, having the program be simulated.
And there were toys out there. Initially, they were toys. They were wireframe images of customer parts and that sort of thing. And you might reduce your programming time by 20%, but you had to do so much rework online that it didn't make a lot of sense. But those tools started to become really effective. And the robot manufacturers like Yaskawa had their own product, MotoSim. When we started MotoMan Canada, that product was in pretty good shape, and we could do some really good stuff in simulating what was going to happen, simulate for the customer what his cell would look like and what his cycle times would be. And today, those tools, well, I won't get too far ahead of myself, the tools are there to really allow you to be offline programming while the robot's online.
When I was in the college teaching, we developed an innovative manufacturing program. It was kind of like my baby. It was a lot of fun to develop this program, and we want to obviously have an automated / robotics component because that's a huge part of manufacturing no matter where you're going to go. And we started like in the inception of the program wondering where are we going to get resources for training, because in my mind I still was kind of dated, being like, where are we going to get a program to sim? It's going to be so expensive, huge computing powers needed. And then I started looking around, and like there's free sim programs that are actually very good, and or you can contact most companies now and they'll have an educational version or program for a college. And I thought that is amazing, because even as a kid who's interested in robotics, you can buy a 3D printer online for $99 and get a free simulation program, and you're learning basically the same fundamentals that you're going to need for large scale manufacturing robots.
Yeah, exactly. And it also, with robots gaining in popularity and the colleges trying to support the industry with training programs for it, it also gave them more bandwidth, because you couldn't afford to have 10 robots in the lab at the college so everybody had a chance, but suddenly you could actually have PCs with simulation software on and teach them the skills that way. And it was also catering to the skill set that young people were bringing.
Yeah.
They were the people that were exposed to video games.
Yeah,
and
they're
things.
used to the screens. They're used to the buttons.
Exactly. So they took to it quite readily. I was coming from rotary dial telephones, so it wasn't quite as easy for me.
Now, when New Tech was the ownership went down, what was your career move there? What were you thinking? This is 2012, I believe you said.
Yeah. Well, I had some personal things going on that timed coincidentally with that. My kids were now either out of college or in college. They'd flown from the nest.
Yeah.
And they were still on the payroll, I guess, to some extent, but they were out of the nest. And I was in a relationship with someone who was living in Ohio, and I made the mistake of inviting her to Southern Ontario in February. And
so you ended up in Ohio.
I did, yes. That decision was made that day. Yeah. So I just looked at it and said, "Here's my opportunity to part ways. My kids are on their own, and I have an opportunity to make a career choice and a move."
Yeah.
And so I made the move to Ohio in 2012.
And did you have a job lined up already on the way there, or
sort of?
Yeah.
So I had some prospects, and I did a bit of consulting for the first maybe 4 to 6 months when I was there, and then I found an organization that was doing laser welding, but was looking to take advantage of their manufacturing capabilities to expand into other markets, and so. I sold them on the opportunity to develop some products, positioning products for robotic arc welding for large equipment. They had some huge boring mills, like 60-foot long capacity boring mills, so they could machine big components, and we could do robotic tracks, robotic positioners, and that sort of thing, and serve a market that I felt was underserved by the current manufacturers. And understanding what the welding requirements were, what the robot requirements were. We were able to design a line of products that we could bring to market to do what we hoped was a better job.
The large manufacturing equipment is very narrow in terms of options.
Yes.
I was working at a company called Dyna Industrial in Canada, and they wanted to buy the largest boring mill that had ever been sold in Canada at that time. This would have been the late 90s. And the reason is because if you can buy a piece of whatever equipment you can invest into, there will be products that go on it.
Yes.
Right. So as a fabrication shop, if you can get a boring mill that has a 200-ton bed that can do 60 feet, guess what? You're going to have 200-ton with parts coming that are 60 feet high.
Yeah.
If not 80 feet high, and good luck, figure it out. Right. So and it was amazing because they actually found a boring mill that was, I think, 60 feet, and it got put 20 feet into the ground so that it reduced the height. And it was this huge undertaking to it. And we were, as employees, being like, wow, the company's going to drop, $30-40 million into one piece of machinery. But that bed was never empty. Like, that machine just produced and produced and produced.
Yeah.
Right? And I'd imagine it's the same in the robotic world.
Yeah, absolutely. In fact, one of our challenges was finding time on our own manufacturing equipment to do our own products instead of working for external customers. But yeah, it gave us a manufacturing advantage because we had capabilities that others didn't have, and as long as we had time on the machine, it gave us delivery capabilities too that others didn't have. So that was a fun experience. Unfortunately, there were things going on with the corporation and its association with its owner that they weren't interested in perpetuating the business.
Yeah.
So it closed very.
Suddenly?
Probably a couple of years after I started there.
Well, that's too bad.
Because we were just getting some traction. We were really, really enjoying the opportunity, and they decided that they weren't going to continue their operations. So found my way to another organization in the Dayton area. That's where I live today. It's just south of Dayton, and they bought into this opportunity as well. They were very well established in the automation field in Ohio, Indiana, Kentucky, in automotive, and they were looking to expand into other markets. And so we basically just moved our capabilities and our products. I was lucky enough to be able to take a few other employees along.
It's almost like just pulling the sign down and putting a new name up.
No, it wasn't quite like that, but there was kind of a package deal for our crew, and we were able to take the intellectual property with us. That was
because it was done.
Part of the termination. Yeah, the company was closing, and there was no need for that IP, so we were able to take that along with us, and so we started right back up again, and that worked out. That worked out for a few years as well. I think the challenge there was, again, the automotive focus and the automotive experience.
I was going to say, that sounds like just why you left Ontario, and now you're right kind of back into staring at high repeatability automotive parts, right?
And we did venture out into some of the other opportunities, but there's an automotive mindset from the manufacturing side, from the integration side, that you can't always apply to those types of projects. So it was a difficult. It was like a blended family that wasn't blended very well, I guess. Great company, great people, and really good products. It wasn't the best fit for me.
Just didn't see yourself long term there.
Yeah, and the challenge for me now is like I was used to 20-year employment. I'm 13 years employment, and now it's like 2-year stints.
3 years, yeah.
And today that's not a challenge. That's the norm. People can switch jobs.
We joke about this all the time. I've been about 7 years is about my shelf life with the company. Now I work for the CWB now, and they're like, "Oh, we're gonna have you forever." And I was like, "Are you?" That's not a given, guys.
Past behavior is a good indication of future behavior. Yes. So yeah, it was kind of wearing on me. I felt, but then again, you also realize as you go through your working career that in the end, you've got to be happy. You've got to be satisfied with what you're doing. And I don't know if any of your listeners sail, but to me it was like you're tacking a way off course, and suddenly you get to the point where you're so uncomfortable you need to bring things back on course. And so I made a course correction, and I was approached by another company, one that I'd worked with in my New Tech days, based in the Netherlands. Fantastic organization, really well run, huge growth, and they had open operations in the U.S. and were looking to expand. And it was a great opportunity to help them move into the market in the U.S. But again, it was automotive.
It's just following you around.
Yeah, well, it is by far the single largest consumer of robotic arc welding. I mean, every year there's so many programs and so many, there's a demand there, because every time they change models, there's going to be new equipment sold and new systems developed. And this company, AWL, out of the Netherlands, was really good at what they did. They were, in my estimation, they're one of the best in the world. Yeah. And so it was really a pleasure to be able to bring their products to customers that were
see how they did it. Yeah.
See how they did it, but one of the things, I guess I'm not altruistic all the time, but you do want to feel like you're helping somebody. Yeah. And so, our customers in the automotive world they're working well with their existing supply chain. They thought that they were getting the greatest solutions. And I was really looking forward to showing them that, there was a better way to do this, and that they could have good equipment that was redeployable, that they could use on multiple programs, because that's a huge deal in the automotive industry. And that was rewarding to be able to help them. The automotive industry, though, isn't really all that grateful sometimes. So.
No, and it's an interesting ebb and flow with the industry, and some of it is very political as well, right? And that makes it a little bit tricky and dicey, especially in terms of footprints nationally, countries where things go, where plants move to and come back from. Yes. It seems to be sliding around all the time.
Yeah,
right?
And the nature of the global programs now make trying to figure out who's making the decision and who needs to be satisfied with the solution when you're working with a company that's based in Europe and manufacturing in the U.S. or vice versa. Yeah. It's really a challenge, and you need a worldwide organization to be able to handle those kinds of situations. And AWL did a great job of it. I had great support from them, and to this day, I have some great friends there. Yeah. But I was tacking in the other direction.
Trying to get away from that car chasing you.
Yeah, exactly. And yeah, everybody has that day where you're sitting at your desk and you just had that one phone call too many that didn't go the way you wanted to, and your LinkedIn is open and up pops a post and hey,
I'm going for it. Yeah.
yeah. And that day it happened to be Eric Boulanger of AGT Robotics, president of AGT. He'd posted, "Hey, we're looking for a sales manager in the U.S. If interested, apply." Huh. Sales
And
manager
everyone
in the
knows
US.
AGT, right?
Yeah,
So,
well, I'd known them, not well known in the U.S., but I'd known them from
Yeah.
different shows, and yeah, they have quite a presence in Canada, especially. They're super integrated into the Quebec market. They do
Yeah.
a great, fantastic job there. So I poked the button, and a few weeks later, we're having a conversation actually at the Steel Show in St. Louis.
Okay,
Was
yeah.
was our meeting, and it was a fit from that conversation in a coffee shop. The deal was done essentially, and for me, the opportunity checked all the boxes.
Mhm.
Representing a Canadian company in the U.S., they were looking for somebody in the Cincinnati area. I'm 20 minutes from Cincinnati.
Perfect.
Je peux parler un petit peu de français, so I could know at least when they were talking about me.
Yeah.
And the industry that they were looking to serve was the structural steel industry, which is the highest mix, lowest volume kind of opportunity out there.
Yeah.
And
with a ton of new growth.
a ton of
Right.
new growth,
Yeah.
and starting to suffer from what was then the chronic skilled labor shortage,
Yeah.
for welding and fitting. And what I wasn't sure of was just how good the solution was from AGT. It looked great, and
Mhm.
I talked to some customers that said they were really satisfied, but their secret was you don't need to program the robot at all. And this was the holy grail that I've been looking for, throughout my career. And so
You just design it and it knows. Yeah.
it's something like that.
Yeah.
And so I said, what the heck, this sounds like a great fit.
Mm-hmm.
And it has been. And so it's now 3 years. Here we are at the Steel Show. So this is we missed a couple with COVID, but yeah, it's been a fantastic experience.
So now, what's your role now today here at the show?
I'm a sales manager for the U.S., so I
Mhm.
look after all 50 states and represent AGT throughout the U.S. And help to manage our resources too. We got an excellent team in Trois-Rivières, Quebec, but a huge customer base developing in all these U.S. states. So I
Mhm.
kind of act as an intermediary for communication to the plant. But I'm quite honestly very busy
Mhm.
representing our products down here. The structural steel market is huge. I had no idea how many structural steel fabricators there were in the U.S. And what started out as a chronic labor shortage 3 years ago when I joined the company, I mean, CWB, AWS, we've been talking about, we'll be 250,000 welders short by this year, 2025 or
Mhm.
whatever. COVID created a situation where the skilled labor market didn't just dry up, it evaporated overnight.
Mhm.
And we went from a situation we were trying to help fabricators to reduce cost and improve productivity to how do I keep my business going?
Yeah.
My fitter didn't show up, my welder didn't show up. I can't make product. I can't supply my customers with the steel they need to build this building because I don't have the people I need to get the stuff out the door.
Yeah.
And our solution, AGT solution, the Beam Master and Layout Master, was exactly the right product at the right time.
So, what are some of the pieces of equipment you guys have brought to this show? Because we talked about how in the past people wouldn't bring such big toys, but now all the toys are on the floor now for people to see. What do you guys got over there?
Yeah, we brought our big toys this
Yeah.
time. We have 2 products in the booth. They're both dedicated products for the structural steel market. One is a Layout Master, and that's a fairly new product for us. We actually tried to introduce it at the Louisville show, which never happened.
Mhm.
So this is really its second opportunity to be seen. We debuted it in FabTech last fall in Chicago. But it's a high-power 3D full-color laser projector that takes the CAD details from the customer's model and it overlays them onto the structural profile. And believe it or not, one of our customers' biggest complaints is they interview candidates for fitting jobs and can't find people that know how to use a measuring tape.
I've heard that lots as an instructor at the college, and it's like I'll get the call being like, "You didn't teach them." It's like, "Yes, I did. They just didn't learn." I don't know
Yeah.
what it is. Like,
So never mind blueprint reading.
yeah,
You can't pull a measuring tape and measure the part. And you know, I chuckle about my experience in the trade part of my high school education, but you know, a lot of those basic capabilities were taught there, and that isn't there anymore. So they can't find people that can pull a measuring tape. They can't measure a part, and they can't read a drawing. So they have a real issue trying to find resources that can fit product. So what we did was we took that skill set and we eliminated the need to measure or to be able to read a drawing. We lay out everything they need to know onto the customer profile. All he needs to be able to do is push buttons on a remote and get the accessory he's fitting to the beam in the lines and tack it.
and it'll tell you if you're off. It says if it's moved, it'll give you like a red light or something.
No, it's not interactive. It's basically displaying this information onto the workpiece. His job is just to get it within the lines.
Okay.
And it's super easy to do. It's very easy to see whether you've got the part lined up. And because we're giving him references in 3 dimensions, it's even much easier than trying to line a part up on a chalk line or a soapstone line. And there's no programming required. Again, these details are taken directly from the customer's model, his Tekla or SDS2 or whatever product he's using, and it translates it right onto the beam. So now you've eliminated all the overhead associated with measuring, with marking the part or trying to interpret the drawing. All he's doing is putting parts on and tacking them in
Probably
place.
increases the repeatability as well in terms of like, if you get a wrong part, it's not going to fit in the lines, and it'll be very obvious quickly that it's the wrong part.
Exactly. We can even, beside the part, we're telling him what the part is. Part number, a description of the part, what the physical dimensions are, how much it weighs, for example. So he's got all these references to be able to make sure he's putting the right thing in the right place at the right time.
So does the laser project from top down? So if you put your hand out, it blocks?
It'll block that. So if you get your head in the way, yes. But it's generally, it's got quite a wide operating window, so you can be fitting outside of that zone where you're going to obscure the lines.
That sounds awesome.
It is.
I mean, it sounds like it would have taken my job away as a fabricator, but
or made it easier so you could fit faster. You
Yeah.
know, and that's really the job. It gives our customers the ability to put more people into that position because the skill set required is lower. So it's been intriguing, and we've actually made a few sales of that product here at the show.
And what's the other cool thing you guys brought?
The Beam Master, actually we've had that product a little longer in the portfolio, but the Beam Master is our solution for welding structural steel. So it's a robotic welding system that is capable of welding basically one piece flow, which is the nature of the job in structural steel. And robot on a long linear rail that can access parts that are up to 80 feet long and 10,000 pounds in payload. So in this case, the customer is going to load a fit beam into the Beam Master, and he's going to download a program that we generated in our software from his details, and push the big green button, and the robot goes to work. It's an untended, lights off sort of situation.
And can it spin the beam around and move it around?
Yeah, it's equipped with a rotator, so it can present all 4 sides of a profile automatically to the robot. We do all of our welding in the 2F position, so everything's horizontal fillets or laps.
Yeah.
And we have the capability to sense the joint to make sure that it is in the right location.
Structural steel correct itself.
Yeah,
to a
structural steel
extent,
profiles are not the most accurate things in the world. So, and although we've got a nice accurate model of the part, and we've developed a program automatically from those details to the location, the nominal location of the parts, W beams, I beams.
They can have a pretty gnarly twist to them.
They can. So what we'll do is we'll sense using a laser prior to welding. We'll sense the location of the part, and if it's within the customer's tolerance, so if they want to send a beam to the field with components that are fit to plus or minus 1/8 of an inch, say, we'll search and make sure that the part's within that tolerance, offset the robot program to match the actual part location and weld it. If the part's missing, or if the part's out of that 1/8 tolerance, the robot will stop and alert the operator to say, this isn't right.
What's up?
What do you want me to do?
Yeah.
And he has the opportunity to skip that weld, or to say that part isn't critical, you can go ahead and weld it where you found it, or you can knock the part off and tack it in the right place and set the robot back to work. If that's
So basically, with those two pieces of equipment, you go from one to the other, right? You fit the parts, tack them on, and then slide it off. So could these be like on the same rail?
Yeah.
And sliding all the way across, just keep moving across the floor?
Well, you don't even have to slide it. So either machine can be used independently of the other. So you can lay out using the fitting system, the layout master on its own, or you can weld parts using the beam master and fit them any way you want. If you combine them, then you fit a beam in one zone using the layout master. When you're done, you just leave it there and you travel down to a second zone. The robot will move on its linear rail to weld that part that you just fit, and then your layout master projector will move into the other zone to allow you to fit
So you
the
can
next
kind of
beam.
just keep going back and forth.
Right. So you only handle the beam once into that rotator in the first zone when you're doing the fitting, and out again when it's finished welding. So yeah, for structural steel fabricators, handling parts is non-value added. It's a lot of the labor
And there's
component.
a lot of risk for safety issues.
Yeah.
Rolling beams is sketchy.
Yep.
It is sketchy, and you cut slings and they fall, and they have weird center weights, and you get to some of the large H beams and they'll just want to take off on you.
Yeah, exactly.
Right.
So if you can reduce or eliminate material handling, you're enhancing safety and you're reducing cost. So that's really what the idea of the solution is to reduce a couple of beam picks every time that you're manufacturing one. And with this solution, because the robot can weld all on its own, it's welding while the operator is doing the fitting using the layout master. He's producing about the same output as 6 to 7 fitter welders.
Yeah.
So it's a pretty productive solution.
Yeah, and that's always a big problem, because the fitter's slower than the welder in many regards. So one fitter can produce well, the welders go. So I remember at Brent we would have like a 5-to-1 rule. One fabricator would produce enough parts for 5 to keep 5 welders busy. But if one fitter goes down or something happens to that fitter, it kind of just screws the whole flow, or the parts didn't show up or something's wrong.
Yeah.
The whole flow of the shop kind of gets disrupted.
Yeah.
And that's really critical when you're manufacturing.
Yeah, it sure is. Especially for folks in the structural steel industry, they're trying to put out more product in the same square footage, and struggle again with the skilled labor shortage. It's really important for them.
Okay, well, we're almost at the end of the interview here, so I kind of want to touch on some of your views in terms of the future of the industry. We've talked about the labor shortage, which it went from like mild warnings to critical warnings, and now it's almost like radical warnings at this point, where we are getting to the point where we kind of don't know what to do. Is governments have put money into training, the colleges have opened the programs, and we're just not seeing the uptake into the industry that we really, really need. What does AGT look at in terms of a company and trying to bring people into the industry? Are you guys working on any programs? I know you come to the conventions, promoting the industry. You guys got stuff going on like that?
Yeah, AGT in Trois-Rivières is very active in trying to promote training, working with local schools. We're looking for a skill set where we've got people with welding experience and robot experience, technology roles within our organization.
Techie people.
Yeah, exactly. And I think welding itself, I've come around to. I actually enjoy the science of welding, and maybe not head down with smoke in my face, but it's still a fascinating process with a lot of variables and a lot of skill required. And if you couple that with the technology, then I think it becomes a really fascinating way to spend your working career. And I think if we could somehow get that information out to young people, they might see this as a great alternative to some of the other things. And it's also a lucrative trade. I mean, being a robotic welding programmer or a robotic welding technician, the manufacturers are lined up outside the trade schools. I don't know what the situation is in Canada right now. I've been removed from it for 10 years, but I know that I was a constant presence at the doors of Conestoga College when I worked at NewTek. We were trying to take the top 2 or 3 from the college every year if we could, and here in the U.S., the welding engineering schools are the kids are getting fantastic jobs, rewarding salaries right out the door.
It's the same in Canada, and it's interesting because it's like that across the country. Basically, any student going into a welding program or a weld tech or weld engineering program, they're lucky if they finish school before they're hired. You know, there's already someone waiting, and of course that's with the caveat that it's usually the top students. But I mean, that's for the listeners. That's on you. Make sure you're a top student. I mean, I can't do nothing about that, right? So, you know, if you're not putting in the time to represent well in your industry, then you're going to be the last ones chosen. But even at that, right now, companies will. I just talked to some companies last night in Canada, and they said, you know, we used to be like, well, we need 300 skilled. Okay, no, we need 300 people with some welding background. Okay, no, we just need 300 people. Just show up. we will do whatever we can to try to get you trained, and we just got to figure this out somehow.
Yeah.
Right?
So I think again the message should be, if you're interested and you stand out, you're going to be a top pick. You're going to make your way through the world of welding without any issues. So I think there's exciting prospects. I think it's scary for the industry because 3 years ago when we started selling, and I started selling the Beammaster here in the U.S., the question was, well, how does it pay for itself? What's the return on investment? You know, how do we pay this back? And the conversation today is, how do I keep making steel? And it is.
How do I get enough product to keep on the machine? Yeah.
Well, no, they can drill it and they can blast it and they can cope it and they can do all that stuff. But when there's no welders there, you can't ship anything to your customer. Yeah. And if they can't find welders and fitters, then they don't have a business. And so it's driven our business. Our backlog now is over a year. So we're selling product to ship next year because we can't keep up with the demand. And our customers they need that now. And so they're looking for that skill set, and if they can't get it, they're looking for some alternative.
So does this mean that you're going to be putting the welding hood back on, and they're going to have to bring you down to the line, get you in there welding?
Actually, Max, I'm older than the average age of a welder, so no, I don't think that's going to happen.
All right. So, and for the final question, what's AGT's kind of future growth plan? What are you guys looking to go? You got new products coming down the line? Any sneak peeks for our listeners of any cool stuff you guys might be doing?
Well, I think we've gone from being a manufacturer of custom automation to now a product-based company, and so the developing the Layout Master and Beammaster products into more capable products because they're software-driven. It's kind of exciting because the hardware you bought will continue to do what you bought it for, but we'll be able to increase the capabilities every year. Every time we do a software change, the machine becomes more capable. So it's like buying a Tesla and finding out one morning when you turn it on, it now goes faster or goes farther. Yeah. And our customers are going to get the benefit of all of our developments on welding capabilities and welding productivity as we move forward. And then, we're looking at Generation 2. You know, as we evolve our programming skills and as welding technology changes, what does Beammaster 2 look like, or Layout Master 2? Yeah. And also, as we look, you look into that space in structural steel, what other opportunities are there in welding or fitting that aren't necessarily on beams, miscellaneous metals and other products? Yeah. So those are the things that we're looking at. How do we take the skill set we have and the products we have and tweak them to manage a bigger market and help our customers even more?
Awesome. So for the listeners that are out there, if you're into robots, kind of nerdy, kind of techie, sounds like a company over here needs you. So, get into school, get into those tech programs. I mean, there's fantastic robotic training centers now all over Canada and the United States where you can learn to program on a variety of different languages, use a variety of different systems, and that's generally enough to get you in the door, right?
Yeah, absolutely. Demonstrate your willingness and aptitude for learning and a passion for this robotic arc welding, and you'll do well.
Awesome, Gordon. Is there anything you'd like to send out as a message to our listeners, or any shout outs you'd like to throw out there?
Just that welding, despite my initial attitude, is cool. And
I agree.
You can make a good living at it and a rewarding living at it. So please consider it.
Awesome. Well, I really appreciate you taking the time. I've seen your phone go off like 40 times. I know that you're a very busy man, and this is you should be over there selling probably 30 machines today, and I'm sure you will. So thanks for taking the time to be with us.
My pleasure, Max. Thanks very much.
Awesome. And to the listeners, thank you. This is our last episode that we're recording here in Denver. This is our third day. We are tired, but it's been a fantastic week, and we've had above and beyond our expectations. And so we'll make sure we'll have to send a shout out to AISC for having us here as well. So thanks to the listeners. Make sure you stay tuned to upcoming episodes. Take care.
We hope you enjoyed the show.